This is the power distribution board that we made. Here's the design of the board. The battery input comes from this terminal, and here we can see this is the 5 volt region and this is the 12 volt region, and we use buck converters for stepping down the voltage. And here we have a linear regulator that gives us the 3.3 voltage, and here we have a MOSFET based motor driver which is responsible for driving the 2 motors of our robot. Here goes the screw terminal where the battery gets plugged in, and here we get the 12 volt region with the buck converter here, and here we get the 5 volt region with the buck converter here, and a USB header is used to power the Raspberry Pi. And here we have the motor driver and the linear regulator to give us the 3.3 volt and driving the motors. And all this gets connected with the board on the second level of the robot using these JST connectors. And as you can see in this board, we are using thick copper planes because it drives high current. And to avoid heat and resistance issues, we use copper cores and thick copper planes for that.
We have another PCB that is the daughter board of our main Prota robot. So in this PCB we have the ESP32, the main microcontroller, the ESP32 chip, and all the other connectors in it. Other than that, we have the sensors like MQ9250 in this PCB, and these connectors that are there are the TFT displays that will be connected to our bot.
The robot required a complicated power system because there were different things working on different voltage levels, and there was a need of a battery management system and a charging system. And to manage all that, we had to develop a complicated and like integrated PCB which had all the systems built into it. And with addition to that, we had to develop a motor drive system which could like drive the motors with high efficiency. So for that we used MOSFET based motor driver IC by Toshiba, and for the power system we used several step down converters to get different voltage levels from the battery. And same goes for the battery management system where we needed the protection and the charging. For that we used an IC from Texas Instruments, and we designed a PCB with all those components using thick planes and copper cores, so that because it needs to serve high current.
Our sensors was based on I2C communication, and we had several sense of the same sensor on the same line. So we had to program those I2C addresses. So for that we used a shift register to program different sensors like the different TOS sensors to give different addresses. Number of pins was very less for our microcontroller board that we are using, that ESP32 board that we are using. So we thought of some different approaches of connecting I2C GPIO pin extender or something like that to solve our problem.
Putting LEDs on a PCB is highly important to indicate power and all. While working here, you are on the edge of the technology that you are working with, like at the edge of innovation. So you get to make new things, very interesting things, and there's quite a lot of interesting problem statements that you get to solve here.
After coming here, I think I've got a purpose as an engineer. Like we had talks on subjects like inclusion, of how cities can be inclusive and how we as engineers can contribute to making inclusive cities or making things which people can use. We recently went to a ROS summit. People there recognized us because we were from e-Yantra. People were like, oh, you're from e-Yantra, and on top of that, oh, you are an intern. So, I mean, they know what it is to get to the finals of the e-Yantra robotics competition, how hard it is to get an internship there.
They were from various startups. They told us if you want to join us, then you can mail us. They gave us their personal mail. They gave us their personal phone number to actually contact them if we want to join them.